This is 9.2 Part B. We're going to convert some angles between degrees and radius. So first, if we started out with degrees and we went to radian, we're going to multiply it by pi over 180. And let's say that you started out with a radian degree, you would convert it to degree by multiplying it by 180 over pi. So these two things are very important. So for example, let's say we were given 135 degrees and they want us to convert it to radians. We take our 135 degrees and based on we are given degrees, we want radian, we're going to multiply by pi over 180. So we're going to multiply this by pi over 180. And in your calculator, you're going to do 135 divided by 180. And you're going to push math under enter to get a reduced fraction. And you get 3/4. And all you're going to do is put the pi right next to it. All right, next example, let's say you're converting a radian to degrees. So we're going to take the 5 pi over 4. And again, look at your chart. It says 180 over pi. So we're going to multiply it by 180 over pi. If you notice, the pi's will cancel out. So we have 5 times 180. We do that in the calculator and we divide it by 4. And we get 225. Alright, now there's a useful diagram for common angle measures that transforms all of your degrees into radian and vice versa. And it's on page 565. You can fill that in the space provided. Now we're going to talk about the arc length and area of a sector. We have two equations. One is for the arc length here, where we have the radius times the pi. Then we have the area of the sector, which is half of the r squared times our pi. And on the diagram, a couple of things we need to go over is from here to here is called the arc length. And so that's what we're finding on a circle. And then all of the area in here, if I shaded all of this, that is called the sector. So I can draw an arrow up here and label it sector. And then our central angle, of course, would be right here. And you can put central angle. And then we also have our radius, which is from the center of a circle, any line going out to the outside of it. So that is our radius. Okay, so for example, we're going to find the arc length and the area. It should be area. Of a sector with given radius and central angle. So here we're given 3 meters as our radius, and our pi is actually in radian form. So to find the arc length, we're going to use that equation I just gave you, which says to take the radius and multiply it by theta. So the radius is 3. We're going to multiply it by 5 pi over 12. So 3 times 5 is 15, divided by 12 in your calculator, and this time we're actually going to get a decimal. So if you just multiply all the tops together and divide by 12, we end up getting 3.93, and this is meters. Alright, and now we have to find the area. So the area of the sector, which was that shaded region, we're going to take half of the radius squared and times it by theta. So half of 3, and we got to square it, times 5 pi over 12. Now this one you might want to do a few different things first. You're going to want to do the parentheses first and square it. So 3 squared would be 9. Take half of that, which would be 4.5. You're going to multiply by 5, then multiply by pi, and divide by 12. And this all can be done in the calculator. you get 5.89. And because we're talking about area, our label has to have meter squared.